Okay, we reviewed the lecture we have a couple days ago, and I understand some of you have a hard time to catch up with the whole entire process model building. Let's go over this example again. The example has two workstation, one of a machining station, one's inspection station. We went through this. Uh, the trick is in an inspection station has a three possible outcome. 80% of a chance the parts is manufactured or are good, go to shipping department. 10% is totally unusable, we call it rejection, and go to trash. And 10% of the parts actually can go back to the machining station, get some minor adjustment, and then come back to inspect it again. And this example, we have two different type of jobs, and job type 1 and job type 2. Arrival patterns, inter-arrival time follow exponential distribution was a 9 minutes and average. 30% of arrival part belongs to type 1 and 70% belongs to type 2. Okay. And also job type 1 has a higher priority over job 2. So we're going to go over this. Processing time for the machining center for the new incoming part are followed normal distribution with the 5 minutes and 4 minutes on the average for type 1 and type 2 with a standard deviation of 2 minutes and 1 minute respectively. Next is the inspection center. Processing time follow triangular distribution with the minimum possible time of 5 minutes, most likely 8 minutes, and maximum times needed is 10 minutes. Again, 80% of good parts go to shipping, 10% are scrap, go to rejection or trash, 10% need to rework and goes to machine with a priority 3 we need it. For the rework part coming back to the machining station, his processing time also follow normal distribution with a mean of 3 and 2 minutes for type 1 and type 2, and standard deviation are 1 minute for both of them. We want to simulate this for 8 hours period and count the number of parts finished for each job type, calculate average time parts spent in the system, and so on and so forth. So now we go through this process again from a brand new let me see, where is that? Start with a brand new simul model, and we'll build this one by one and see how that goes. Okay, we're quickly going with the source, 2 server, and 1 sink, actually 2 sink, 1 for scrap part, 1 for the shipping. I'm going to call this shipping department. This is rejection, and then call this machine center, call this inspection station, and I'm going to arbitrarily throw in some path right here to connect them together. And this part represents the backflow of rework parts. So the good part going to shipping right here, and the rejection going here, and rework going right here. So here I'm going to change, this is called rework, path. And this path we're going to go say trash. And this part called go shipping. Alright. And since the outcome of the inspection are so-called probability based, so here I'm going to set the percentage of each one of the possibility outcome to 80%, 10%, and 10%. Okay, so 80% for going to good part go shipping, 10% go into rejection, 10% for reject. And also I need to highlight this output node, and instead of using shortest path, I'm going to using by link weight. So follow the weight based on this and distribute that way. I'm going to grab a for turn it, call it parts coming in like that. All right. Maybe I'm going to start coming in. First is the parts coming in. Actually, need the definition of a few things. I need to define the parts with several different usage I want. And first I want to do job type, status, and priority right here. So I'm going over to the model entity definition state. I'm going to define a few state variable related to the model entity. I'm going to add two of them. One of them I'm going to call job type, represent what type of job it is, and the second one I'm going to call the status. I already said we already said that status in the class, when job types equals to 1, that's the first type of job, and job types equal to 2 is second type of job. Status equals to 1 represent newcoming parts, and status equals to 2 represents the rework part. So we define these two user-defined state variable related to entity itself, and also we utilize one of the predefined state variable for the entity called priority. They already defined it by CML, so we don't have to duplicate the definition. So that's just using that in the process. Go back to the models. When we generate that part, when we generate the parts, here we're using entity type called part. Before we leaving the create block, the source, we're going to assign a few things. We're going to assign first the job type based on random distribution. So we're going to model entity job type and define it based on the discrete distribution. So we have job type number 1 represent 30% of the chance, and job type number 2 represent the rest of the 70% using a discrete distribution. After I define the job type, I can add a status for the current incoming parts called model entity status right here. And for that, since this is a new incoming part, always have a status of 1 in that case. Then I'm going to define the priority for the incoming parts. Since the priority type coming in represent 1 or 2 based on their job type, so I might as well using their job type as their priority as well. So the model entity, so-called priority equals to its job types. Okay, so these are the things we can sort of go over. Machining processing time, inter-arrival time follow exponential 9 minutes per second. So we make sure this is minute. And inspection time follows a triangular distribution with 5 minutes minimum, 8 minutes most likely, and 10 minutes maximum. And that's also minutes in units. The only thing we have right here is the machining processing time, which is not constant. It depends on what job types and status, they have a different processing time. So below we're going to show how we're going to set up this variable processing time. So first we go to set up a state variable. Okay, we call that's using wheel. We call the processing T time. How's that? Okay, so we're going to use this processing time as part of but this is we're going to define two data. First data table. I'm going to call it table 1. Table 1 remain called the mean value. Carry all the value of mean. Adding a 2 column. Okay. And the first one is new. And the second one is reward. And the processing time accordingly, it should be 5, 3, 2, 4, and 2. These represent the mean for the new part, type 1, type 2, rework part for rework the part for type 1 and type 2. This is the average for each one of the processing time. Add another data table. We call the standard deviation value for that, and adding 2 more as well. And this one is new part, and that part is reward. Okay, so I have 2, 1, and 1, 1. So this represents the standard deviation for new part number type 1, new part type 2, rework part 1, and rework part 2 for their standard deviation. And then we're going to back to the definition, define a processing time called mean processing time. Instead of based on the scalar, we can define it as a vector matrix. Here I'm going to initialize them with a matrix from table and choosing mean value, and okay, and the processing time will be actually time. So create another real value and should be standard deviation. Okay, and this is also defined by a matrix from value and going to the standard deviation value, and this is let's do that without any unit. We define the unit later on. So we define 2 new state variable, which is their initial value based on the data table here, mean value and the standard deviation value. Okay, so we formally define these initial parameter for our process. Then we go back to use this in the machine part of a processing time. I'm going to drag this a little bit longer so you see this processing time portion. And I'm going to using a normal distribution as described, so it's a random. And based on normal distribution. And the mean and the standard deviation both following are a 2x2 matrix. And the first one is indexed by model number first, and then a job type, and then the status. So here what we have is model, entity, job type, and based on the model entity and status. So that means I access the different means using job types and status for each one of the entity. Same thing, I'm accessing the standard deviation matrix using the job type and model status. Model entity status. All right, I'm done here, so we can see if this model runs properly. So each one of the jobs actually go through machining center. And speed out a little bit. See parts coming through. Okay. Some of them go to shipping, some of them go to reject, and so on and so forth. And since we redefined the path called reward path, trash path, or go shipping path, if we run the simulation through fast forward, we can see from the result actually how many proportion go into the shipping, how many proportion go into reward, how many parts go into the trash. So here we have about 28 parts going to the trash, about 19 of them going to reward, and total about 128 going to shipping department. The part actually generate totals 170 to begin with, and you have a total 156 leave the system, including the shipping part, the trash, and the reward, everything. So this is all there's to it for the process. Last time I also mentioned we might want to distinguish the part different type with a different color so we can visualize a little bit better. So what we do is right now what we do is we get this part and add a new symbol. If you can see that both symbol 0 and symbol 1 has the same color. I'm going to change the color for symbol 1. Zoom in a little bit so you can see it a little bit better. I'm changing the color for part number 1. If I'm changing in 3D manner as well, do that. So the part entirely is going to be red, okay, for the second type of part, and first one will be green and red, and distinguish those. Here I have a symbol 0 represent the part number 1. Red part represent type number 2, but they have index of 0 and 1, so we need to do some tricks on the resource portion. Okay, adding the assignment for changing the picture. So changing the picture is using a property called model entity picture. Okay, model entity picture. So we have part number 1 represent symbol 0, and part number 2 represents symbol 1. So therefore, I'm going to use the model entity and job type as -1 as one of those as we speak in the class. So job type equals to 1 using symbol 0, job type equals to 2 using symbol 1. So we go back to see if it works properly. So we can see some of the green part coming through, some of the red part coming through, and therefore my solution is about the same. It just visualize them a little bit different. So I'm conclude this part of the small lectures, and about 20 minutes we can look at the whole process. All right.